Right, we are good to go. Screen, audio's good. All right, go ahead and do timestamps. Intro. So what we're going to be doing today is we've got our node exporter page. Useful. We got node exporter. I'm pretty happy with it. We have all kind of the static information up here. And then we have these, what are these called? Stat panels with the line, the history line. So yeah, this is all pretty good. We have CPU usage broken down by what type of usage it is. And then we have CPU load, which is basically like how many processes are requesting access to the CPU. So this can spike up quite a bit higher than your actual CPU. So like when you hit 100% CPU, your CPU load might be like 1.5 or 2 or something like that. Basically, it shows you how overprescribed your CPU is when it's busy. So that's good. Memory breakdown, just memory. This is kind of interesting memory commit ratio. It's how much memory is committed by processes that they want. The limit that you have is the denominator. Basically, this is how much the processes say, hey, I want 5 gigs of memory. They're only using 2 gigs at any given time. This shows you how much they're using. This shows you how much the processes have requested. And so this is useful just to see like, oh, if these processes got busy that were running on calculating walrus, then we would go past our limit. So that's fairly common with Kubernetes stuff. If we were to look at, say, one of the agent nodes from prod, maybe. Yeah, so you'll see here, we're not using that much memory, 30% of it, but we've got enough pods that if they all started using their memory limits, we would end up here. I don't know if it's memory requests or memory limits that corresponds to this, but anyway, I'm pretty sure it's memory requests. Look at the rest. We've got our disks. Got a drop down here in case they have multiple disks. You could select which disks, but this ends up repeating. So I could show you, for example, agent core prod, which we were just on. One of these. These have multiple disks. VDA, VDB, VDC. These are extra disks for Rook-Ceph, for Vitess, and for Kafka. It would be nice to tie in the label somehow to what they actually are. And maybe I'll do that at some point, but I'm not super worried about it because you have it up here. The reason VDB doesn't show up here is because it's a raw disk. It's passed in. So anyways, but the benefit of having this kind of selector is that if you wanted to not see all of them, you didn't care, you could just select one of them. Same thing for networking. Tomcopy is one of the Proxmox nodes. So we have our disk read latency. This is kind of interesting too. So disk read latency, this is how long from the OS's perspective something requests to write to the disk. How long did it take? And this is averaged across all the processes. So it's not like a specific one is measured every single time because that'd be too expensive. But this is like, you requested 10 times to write to the disk and you spent 2 seconds in the queue waiting to write to the disk. So you can see here it's about 200 microseconds to read, 160 to write. Yeah, that's about what I would expect for an NVMe SSD. But then an interesting thing is if we were to go to global DNS isn't doing any reads of the disk, but it's writing periodically. Maybe logs or I don't know what it's writing to disk. But you can see here that global DNS is at 2.6 milliseconds for writes. And the reason for that is because global DNS is using Ceph with inside a Proxmox, so this has to do networked storage. It doesn't have to be that way. The reason it is that way, that global DNS is using network storage, even though we have 3 of them, is because let's say one of the Proxmox nodes goes down, then global DNS 1 would go down for some period of time. Global DNS 2 and 3 would stay up. And the benefit of having it on network storage is that when that node is down, if it's down for a long time, it can just shift over to one of the other nodes, and now all 3 DNS servers still work. So you have a period where one of them dies. The other 2 can still handle the DNS request as long as the clients retry. with the other DNS servers. But this makes it so that when you use network storage, you can have all of them always running. We go back to calculating Walrus, one of the Proxmox hosts. You can see the network traffic is very symmetric here. That's what's kind of interesting too. So this is receiving bandwidth, transferring bandwidth, and then number of packets. And so they're pretty much the same here. Down here at 0, this is a second network device that this Proxmox node has, because it's just got another NIC that's not being used. That one's 0. If we were to go to global DNS though, you would see this, which is kind of nice, which is you can see that these are not symmetric like they are for the Proxmox host. Go back to calculating Walrus. Context switches per second per CPU. So context switches will depend on the number of CPU cores you have. This is normalized. 10,000 is kind of the warning indicator there. File descriptors. There's like a hard limit on how many file descriptors, but generally if you're opening up a ton of them, something's probably wrong. A lot of times it means you're binding ports. You shouldn't be binding like more than you should be. Things like that require file descriptors. So yeah, pretty happy with that. I was thinking it'd be nice to show the IP here, but I don't have a way to get that from the node exporter metrics right now, unfortunately. Yeah. DNS. Yeah, it's request rate, latency, P99, 95, 90. We've got the DNS request distribution. This is very similar to the this is latency, but it's the distribution, so you can see the buckets. So, this spiked up to, what did this spike up to? 240 milliseconds at one point, the P99. But did we have requests that took 1 second or 2 seconds? No. Even though, like, if I were to hover over this area, we can see it corresponds here to this area. And so you can see we kind of had a lot of requests that were in these buckets. They were taking hundreds, maybe, I don't know what this is. This is 32 to 128. And we had some requests taking 128 to 500, but we didn't have any requests taking 500 milliseconds to a second. So this is very useful to see, like, were all your requests timing out, or were like some percentage of them timing out, or were some of them just slow? This is very common when a service goes down. Like when a service goes down, or maybe like a pod goes down, and then some of these network requests start timing out, it'll show up as high latency and you'll see that, but you don't know what the actual behavior was. And so with the heat map, you can see what the behavior actually was. And so here, there was no kind of error or anything. It was just things got slower. Serve, fail, NX domain, no error. What type of DNS response comes back? Over here, we have the different types of records that are being requested. Most of them are A records, which is interesting. These are the ones going to global DNS. These A records, yeah, A records, I believe we do no error, maybe? Now I'm a little bit wondering about this. No error. I think, yeah, no error just means you didn't return an error. You may or may not return the responses in the DNS response. So here, these A records, I think we send back no error with an empty response, which generally most clients will treat that as, okay, let me try to do the AAA or quadruple A, the IPv6 record. So these IPv6 records also come back no error. So both of these categorize as no error, but the the AAA record, quadruple A records will return address. And some websites don't support IPv6, so you have to do DNS64, and also NAT64. So basically, like, if these servers can only use IPv6, some websites don't have IPv6 support. So what you do is you basically implement a NAT64 on your router, okay, wherever you need to put in front of all your traffic. NAT64, when you use DNS64, which returns a record like generally, the way this works, DNS64 pre, is you have your DNS server. When you get requests, a quadruple A, quad A record, And it does a request to the public DNS servers like Google, and it says, hey, I want the quad A record for, I don't know, Twitter. Twitter says, I don't have a quad A record because we don't have an IPv6 address. When that happens, then your DNS server will also do an A record request for the IPv4 address, and it'll map that IPv4 address into this DNS 64 prefix space. So IPv4 only has 32 bits per record, and those 32 bits get mapped into this 96-bit space. And so now when your servers are trying to talk to an IPv4 server, they'll use this IP address, and your NAT64 will translate that into the real IPv4 address on the public server. So your servers don't even know about it. They think they're talking to this server. They're actually talking to an IPv4 server through your NAT64. The point is that you need DNS64 set up, and DNS64 will return quad A records, and then I explicitly block A records because a lot of Go services, I think like the built-in Go client, if it detects an A record, it'll try to use the A record even if the server doesn't have an IPv4 address, it'll still try to use the A record. So I actually block all A records on my stuff. Cache miss, yeah, this is pretty self-explanatory. Cache hit, basically, is it in the cache? If it's not in the cache, it looks at its static records, which are just like hard-coded records in the core file. If it finds it in the static records, it's blue. Doesn't find it either one, it has to actually go upstream to the public DNS servers and pull it. It's the cache miss. So that shows negative versus positive cache size. So this is how many cache entries there are for this server, global DNS 1. Positive means that it got a response back. Negative means it got like that domain doesn't exist or something. So it still caches that. It caches that the domain doesn't for some period of time. Then we have upstream latency, which are how slow your upstream servers are. One thing that's kind of interesting to look at here is, there's Cloudflare public DNS, Google public DNS. I'm on Starlink, so these results would only really apply to Starlink and Starlink in my area. Starlink, I'm in sort of the Portland area. When I hit Starlink, it goes to Seattle, data center in Seattle. And so, anyways, these results are going to be specific to being on Starlink and in that data center because these providers will have peering with different data centers, which make faster paths. But so, actually, what happened last? Okay. So if we look at the last 2 days, yeah, this has switched a bit. I wish I had more records, but I've been messing with this too much. I've been messing with the tags and stuff, and so I've been like losing metrics data while I do that because just the way Victoria metrics works. I mean, I don't need the data. It is interesting to look at. The other day, when I was looking at this, Google public DNS had worse P50 latency, which this is about what I saw before. It was like 25, 26 milliseconds for Cloudflare public DNS, the average latency. Maybe Google was like 32 milliseconds. So it was like 25, 27, and 32, like very close. But the thing I saw was that sometimes the average latency to Cloudflare was very high, like 200 milliseconds, whereas Google's like highest average latency was maybe 80 or 90 milliseconds. The thing is, that was also like, I have very few requests going here, so it's hard to tell. I don't have a lot of public records requests. And also they get cached. So when there's more traffic and stuff, maybe that'll change. But I mean, ideally, it really shouldn't change. You shouldn't be doing a ton of records requests in general. And that's kind of the nice thing about the global DNS stuff. The bad thing about the global DNS stuff is that if the global DNS goes down, none of my stuff can do DNS anymore. The good thing is that, it all DNS gets funneled through that. And so you can do caching and not kind of hammer upstream servers and stuff like that. So anyways, when I was looking at this a few days ago over like a 2-day period, Google's public DNS maybe had like the P99 maybe had a max P99 latency of like 200 milliseconds, 240, like we were saying here. But Cloudflare actually had like a 500 millisecond period where the P99 had gone up to 500 milliseconds. Now that I'm looking at this again, I think I just don't have enough data here. And so I feel like it's kind of cherry picking. So maybe we can't draw too much from that, but it is a thing that's nice when you have this chart. You can actually see, is one public DNS server. A lot of times people like measure average latency, and that's fine. But for like real servers or services, you care mostly about P99 latency. You don't actually care that much about PFID as much. Like, I mean, if it's 32 milliseconds versus 27, sure, it matters. But like if my P99 latency is 200 milliseconds versus 500 milliseconds for DNS requests, I care much more about the P99 latency. And most of the analysis I've seen online, people only measure the P50 and don't give you the breakdown of the latencies. So anyways, yeah, that's that. Upstream failures, have any of the upstreams like returned any failure responses, or maybe like connection timeout? I don't know what other things would count as failures, but so yeah, pretty happy with these. I think they give a lot of info. They've all got thresholds. Yeah. So here, what I need to do now is I need to check all this stuff in. I think basically not make a task here. Maybe I did that on yesterday. I did that on yesterday. I've got a bunch of stuff that needs to be committed. So I'm going to go ahead and do that now. Let's see what it said about this first. So there's just some small touch-up stuff with metrics labels and alerting that I want to take a look at. Get this stuff committed, get it out of the way, and I'm pretty satisfied with what I ended up coming up with here. Basically, we'll have some consistent labels across our stuff. So we have these kind of labels that I want applied to most things. Runtime type, is it a bare metal server? Is it a Proxmox VM, K8s pod, GCP VM? The context of the runtime, so is it like my bare metal servers are in the garage, so that would be home lab prod. Maybe I could like set up some other servers in the garage that wouldn't be prod, so that's why I add the prod suffix there. Proxmox prod, which is just the only Proxmox deployment I have right now. K8's core prod is one of the Kubernetes clusters. We have other ones. And then GCP Kiwi app prod. This is the project namespace. And yeah, this is the project namespace for GCP. So that's the context. It's kind of like, what is it running? Like, what is the environment of where it's running? So what is it? The VM, what kind of VM? Where is it running? Runtime host is the actual node that it's running on, if it's running on a node. So yeah, like it could be running on Calculating Walrus, which is one of the Proxmox nodes. It could be running on the Kubernetes node. It could be running in a GCP zone. Because like for the VMs, I don't know what server it's running on or anything. So system context. System context. This is kind of like an arbitrary label. It's like kind of hard to decide on this. But this is just like, if you had a bunch of metrics, for example, for core DNS, right? The global DNS VMs have node exporter metrics, and they also have core DNS metrics. And maybe you want to be able to have a single label that lets you see all the metrics across those two sets of labels. And this is what kind of lets you do that. It's just this one arbitrary label that gives you some flexibility over like, what is this group of things and what does it belong to? So instance name, just a name. I mean, like different things like node exporter will have a thing called instance. Other things will have a different thing called like they'll all have their own names for this. So I just wanted this consistent instance name that I can use across any of my metrics labels, my metrics. And then for some stuff, we'll have like node role. So for node exporter metrics, we'll have node role, which is like Proxmox node or K8's node. For DNS VMs or pods, we'll say like, you know, what the role is, which is the global DNS or cluster DNS. Gateways, if we have like traffic or if we have other proxies and stuff, we'll give them different roles. Components are, as far as I know, it's only for Ceph right now, which is like which component of Ceph is it? Ceph has its own thing, its own label for this called I don't remember. Ceph has their own label for this in their Ceph metrics, but it is nice to just have like a standard convention for this, so that you can use this on your dashboards and kind of not have to figure out for this label what is it supposed to be. That's always an issue. So that's what we set up, but I got to check in these changes. And then I want to do something fun because I've just been doing dashboards too much. So I threw in this. Maybe, yeah, I don't know. Maybe I can make this into a short or something. So that's maybe something I should, in general, is like, I don't know about every day, but every couple days or so, it'd be good to do something where I can make it an isolated thing like this. Um, 100 gig networking. This is what we want to test. So I have 100 gig networking. There's a 100 gig switch between the Proxmox nodes. In theory, the pods should be able to talk to each other across Kubernetes nodes at 100 gigabits per second. In practice, there's a lot of reasons that doesn't work. The Proxmox nodes can definitely talk to each other at 100 gigabits per second. But as soon as they're in VMs, you have virt.io for networking, which has queues and it's its own whole system for how networking works inside of a VM. And I found that the overhead is kind of high. The CPUs that I'm using, these Epic, I think it's 2nd gen Epic CPUs, they don't have the memory bandwidth, I don't think. Like, they don't have excess memory bandwidth per CPU. You really have to kind of distribute the load across the CPU cores. And so I found, like, if I do everything right, if I, say, give, like, 32 queues to each VM, each, like, say, Kubernetes node VM, they can maybe get to, like, 80 gigabits per second. But there's, like, the more queues you add, more virt.io queues, the more you're going to have interrupts, context switches, and interrupts if you have a bunch of VMs on a node, which is what I have right now. I have 3 Proxmox nodes that have a ton of VMs on them. So if I gave each of those VMs 32 queues, it would not be great. So I did some testing, and I think I ended up with like 4 queues or 8 queues. Ended up being the right number. If we were to go look at that. Got it here, I think in hardware. Yeah, 4. I went with 4. I found 4 gives like 40 gigabits per second. And that's fine. The thing too here is you have a bunch of VMs, right? So each one can do 40 gigabits per second as long as you have 100 gigabits between the Proxmox hosts. It's like you have a 100 gigabit bus. So it's, even if one's using its full 40 gigabits, it essentially can't use up all the bandwidth on its own. Yeah, it would be nice to do that intentionally instead of just because you can't. But where we're at. So I wanted to test this some more, and the other thing I wanted to test was iperf 3 uses threads and iperf 2 uses processes, and I haven't been able to get iperf 3 to perform that well compared to iperf 2, but I have seen people use iperf 3 in videos, and they got like 100 gigabits per second or more. I don't know, a lot, even like 8. It was not hard for them. So I don't know why I don't, and I'd like to explore that a little bit. So that's what I was going to test here. And then also just try to replicate that on the pods and stuff and see if I could just use iperf 3, because I'd prefer to use iperf 3. That's kind of what most things support these days. The other thing that would have been good before this stream would have been to put I have a new 5 gig NIC, USB-C for my laptop. I have a 10 gig switch for my desk setup. I generally SSH into a VM on here so that I can have full performance within that switch and that environment. But I have a 10 gig switch on my desktop, but I think right now I only have a 1 gig Thunderbolt 3 dock. I looked into getting the PS5 CalDigit dock, but it has 10 gig, but it's I think $500 or something. So you can get these little 5 gig USB-C things for $20. So 5 gigs is enough for my laptop because, like I said, I try to avoid using my laptop as much as possible. Because you're just much better off trying to do this stuff within this environment. You know, you're talking about 100 gigabits per second versus 5, 10, or if you were like remote, say if I was at a Starbucks or something, I would be down to 5 gigabits per second, right? And you're talking about a factor of 4,000 or something. I don't know to do the math. 5, I don't know, a lot. And so yeah, it's good to just as a practice do this. If you were at a hotel or a Starbucks or who knows, where you're not like on-prem like me, where you have 10 gig. So that's what we'll do for fun. Let me go ahead and clean up this stuff, and then we'll see about doing the network testing after that. The thing I was asking right now, I'm taking a look at, is we have these node exporter alerts, and we kind of have this setup here where we have like critical alerts and warning alerts for each different type of thing, even though they're all like Proxmox node alerts. Like here, global DNS has global DNS critical alerts and global DNS warning alerts. And then in that, we have all of the like node alerts and stuff. But there's like some levels of indirection here. And before it had like one node exporter file. It was hard to follow. And so I thought it'd be nice to kind of separate the settings for each of these into their own files. And then the base settings here. These are kind of the base alerts that all of them get once you create one of these. But I was wondering how it felt about this. Okay. How are my levels? I think we're good. Yeah. Now, so I asked you what I thought about kind of this setup, organization of these alerts. I don't particularly like it. It says, here's my assessment. Victoria metrics alerts. What works well? Node exporter folder pattern is clean. I agree. This is good now that we just changed it. Core DNS alerts has a nice config-driven approach. Yep. Proxmox, Kubernetes, monitoring, Core DNS. Okay. Wrapper file redundancy. Global DNS is a 10-line wrapper file that just re-exports the node exporter global DNS. Same pattern for Kubernetes and Proxmox. Yeah, so that's kind of interesting. So in Core DNS alerts, that must mean these get imported directly. Yeah, the critical. Yeah, Core DNS. Yeah, it just did this differently than it did the other one. This one, basically, it imports the Core DNS alerts into here. And if we did it that way, we could just import the node exporter alerts into here. I think that might be better. Yep. Yeah. So it says potential improvements, flatten the wrappers. You could have node exporter contain everything, the node exporter folder contain everything, including platform-specific non-node exporter alerts. Yeah, so it's saying like right now I'm kind of separating it by the exporter. And so instead of saying something like I could have, you know, a node folder and I could have all the node related alerts. I don't know. I like it in theory that you have a node I like it in theory that you have a node page with all the node alerts. I think in practice it's a little bit hard because you if you have all of the node alerts together, regardless of whether the node export or not. What happens if you have an alert that's across two different things? Because in that case, you could imagine instead of core DNS alerts, you have DNS, you'd have node, and you'd have DNS. And so for DNS, it's kind of weird because you'd think in DNS maybe you'd want CPU metrics and stuff, make sure DNS is still healthy. That's why I kind of lean away from doing it based on what the things are, because then like I'm gonna have node alerts that have CPU, and in DNS alerts I'm gonna have CPU. That's kind of the same reason with the dashboards. I actually did it specific to the exporter, the generic dashboards. That way, like no matter what, if it's using that exporter, that dashboard's good. Instead of like when most people create dashboards, my experience, they put a bunch of metrics onto a dashboard because they say this is the node dashboard. And what happens is that some nodes have all the exporters, some of them don't. Some of the exporters are different. Some of the labeling ends up being different. And so you load one node on the dashboard and like half of the graphs don't, half of the panels don't render because, you know, it doesn't have the right exporters or whatever. The same thing I feel is true about this, which is if you had a node page, you know, maybe global DNS doesn't have access to that same metric that you have for a GCP VM or something, even though you're running node exporter on it. So I like keeping them separated by exporter, but we should definitely make core DNS the same structure as node exporter. But then I think it's probably better to get rid of the wrapper files and just import all of the just import the set directly into index.txt. Clean this up, take a look over all the other changes, get the all committed. Right. Ooh, let's see what we can commit. There's a lot of stuff. Labeling changes. Really got to look at all these because it really fucks up some of this stuff. Deferral. Good. This was just some improvements to the alert dig. This is just reducing the alert manager logging, all the Grafana stuff. Your environment. Is templates. We have alert groups. We have a groups folder with clusters. So this one actually works differently.
I created a new coredns folder with a TypeScript index file, shared types, and generator, added per target coredns alert configuration files, and removed the old coredns alerts TypeScript and global DNS wrapper files. I then updated the main infrastructure index TypeScript file to import directly from the new folder structures, ran TypeScript type checking, linting, and lint fixes, and verified the final directory layout. The project now has consistent exporter folders for Node Exporter and coredns, with combined alerts in the top-level index.
This is already having the issue that I just talked about, which is that I have these Node Exporter alerts. Then I also created, at some point, like alerts for each cluster. And these alerts are useful. Kind of general health of pods. But like an obvious thing you would want to know here, I think these are like, this should also be named based on the cluster exporter. I think it's Kubernetes exporter. Because like when you think of cluster, you think these are alerts for the app cluster, and so maybe I should put a CPU alert in here for the node itself. But you already have a node alert for a CPU alert for the node in Node Exporter, right? So you don't want to think of this as like a grouping of the thing. You want to think of it as the Kubernetes exporter alerts, so that you know where to put things. Because it drives me nuts when you have things in 3 places. It's not just that you have things in 3 places. It's when you want to do something, you don't know where you should put this thing, because there's just not clear boundaries of what's what. And even if like I prefer, like say for example doing it based on exporter, even if it has like some slight issues, if it's just obvious to me where things go when I got to do things, or where to update things, or how things should change, that saves me so much time and thought and discussion with myself. So I much prefer this type of structure where it's very clear. So now I'm looking at alert groups, cluster, and at alert groups / infra Kubernetes. And I think that clusters kind of follows that pattern that I don't like, where the grouping isn't explicitly by exporter. It's more of a logical grouping. Can we refactor this so that these alerts are grouped by exporter, and then probably do a similar setup to what we did for coredns node exporter? What is your node exporter, where we have overrides for each specific cluster. Kubernetes. Global DNS cluster. Yeah, close. Oh, what did it just do? What the fuck did it do? Not what I meant. I see. We should probably get rid of migrate the Kubernetes groups. Kubernetes alerts for the same reason. I think the way this should work is that would create a loop. Okay. Is that index.ts in each exporter directory should export all of the warning/critical alerts for that exporter. We probably need a separate file to define the configs, base config, alerts. And then we have each corresponding file to set the config for that set of alerts. Can you create a plan to do this? And then I'll unpack so we can
I explained the existing alerts layout, proposed reorganizing them into exporter-specific folders, each with an index file that re-exports all alerts, and detailed the key changes, such as deleting the old clusters folder and moving the Kubernetes, Proxmox, and monitoring files into the new exporter directories.
Let me create a plan. Node exporter. Yep. Or DNS. Yep. I separated these because I think I wanted like cluster alerts versus node level alerts. Do you think you really need Kubernetes cluster script, or should they be one thing? Oh. Oh, that's the current state. The new state. To read. Node exporter index. Big prox mox. Yep. Kubelet index. Yeah, why didn't it create an alert stub? Do you think each folder should have an alert dot? Yes. I was thinking exports needed to be separate from alert type definitions. Type. Functions because of cyclic and choose. Good. Good. This is low.
Want me to update the plan with this correction?
You're right, yeah. Pattern should be alerts. Okay, go ahead and create the a little bit of fun today. Network testing. If we don't get to the graphs, then we don't get to the graphs. It's just the way the cookie rolls. Talking to myself in these streams. What is his name? Harry? Harry.
I created Refactor plan, MD, with a detailed plan that outlines a new structure of 10 exporter folders, each containing alerts TypeScript, configuration TypeScript files, and an index TypeScript that re-exports the alerts, and a single root index TypeScript that combines all exporters into final alert groups. I explained the folder pattern, the 4 implementation phases: fix existing folders, create new exporter folders, add a new root index and delete old folders, then verify with typecheck and lint, and provided an alert mapping that shows exactly where each alert will be moved.
Okay, what I was gonna say is that Terry Davis, I just read it, Terry Davis. He was streaming all that time and talking to himself. And like, I mean, it's pretty hard to talk to yourself like this. But it was just reminding me too that I have the text-to-speech stuff, which is nice. I like it. But in my house, there's no voices, no human voices. I mean, I don't speak to myself. So if I hear a noise at night or something, before the text-to-speech stuff, I would just think it was, I would never think it was a voice. Like it would just be some noise, or you know what I mean? That you would hear and you wouldn't think anything of it, unless it actually sounded like a voice. But now, like if I hear something, my brain like thinks, oh, maybe it's the text-to-speech voice, like giving you a notification, and so like you kind of hear it as that voice, and so it's like I have this voice in my head now, in the place I live, which is what I want. Okay, I wrote it as a refactor plan. I wanted it to do it as a to-dos, but fine. The universe is speaking. Listen. Do-do-do. One thing I wonder about, so with some of these issues that I've reported, like some of the individual, I mean, even before the AI stuff, some open source maintainers like Patrick, who does Strawberry GraphQL, are like super responsive and just doing a ton of work and like get stuff done very quickly if it's a small task. But now with the AI stuff, like if it's simple and your thing's open source, you can just have AI generate like the solution, and you can look at it and be like, this is good, or just give it a quick fix. Like you don't even need to write the code, you know? You can just say like, this is what's wrong, and you don't have to have this back and forth between the PR writer and stuff. Because, you know, for me, a reason I don't like doing PRs a lot of times is because there's like some specific setup I got to do, and it's just not simple, and I maybe miss a file or whatever. So like if it's less than 5 minutes, I'd rather the maintainer just do it, because then there's just no back and forth. And some maintainers are like that and they prefer that. My point is mainly that I do think that some projects, like this one, for example, if the maintainer starts using the AI tools, they can do all these easy tasks in no time. Like as long as it takes to read the issue is how long it takes to fix the issue. So I do think we'll see a divergence between sort of newer, I think that we'll see this in companies too, between newer, smaller open source projects that adopt the newer technologies and really are just able to fix every issue users have. And like I think about this as a big benefit for open source too. Go ahead and start implementing that refactor. Like this seems like a huge benefit to me with open source, because one of the problems with open source a lot of times is people report all these issues and you just can't keep up with, I mean, there's too many issues. So now, like people reporting all those issues, you can actually fix all those issues. And so you can just make your product better in a way you couldn't do before. At least fixing little stuff. I don't know that big stuff or refactors are really possible. If you make bad choices, like you're not going to be able to easily refactor your whole architecture of your huge thing. But a lot of times you'll see open source projects where you're like, why don't they fix this? For example, Grafana doesn't have monospace fonts. Like, why? Like, it seems like that should be just a very possible thing to do. But some things are much smaller than that even. But my point is mainly that I do think these smaller open source projects and also smaller companies that really use the tools in a better way can be much more adaptable. I think a lot of the bigger companies and bigger open source projects are going to be hesitant to adopt this stuff quickly, or they'll adopt it in a way which is like doing the things the way that they were always done before. And I just don't think you get that much value out of the tools if you do it that way. For example, one thing I talk about with people sometimes, like all the big tech companies do 100% code review. And even before the AI stuff, it never particularly made sense to me because they never do, almost never at large companies will people do pair programming. And pair programming seems great to me, like just periods of time where you do that, because you learn all this stuff about how the other person works with the code base and what they look for and what they're doing and what they're paying attention to in a way that you just can't through a code review, because the person's not going to explain every single thing that they thought about to do stuff. So it was always weird to me that there was 100% code review and basically 0% pair programming. And the thing with 100% code review is like, I mean, you wrote the code, you're responsible for it. Like if you need code review, then ask for it. But the idea that like you make people do code review, it's like just hold people responsible for the code they write. I think part of the issue you end up with at large companies is that they don't even know who they're hiring. So they don't know if they can trust the code coming in. And that's a problem, right? Because you could have people that are, you know, agents from other countries, or even just, you know, bad independent contractors trying to make money off of you, who basically land vulnerabilities in your stuff for, you know, hacking groups and things like that. So that's a reason to do 100% code review, is basically you've hired so many people you don't even know who's working for you anymore. You can't trust them. But like an example of what you could maybe do instead would be to have a group that's doing code review explicitly and is very focused on that, like sort of retroactive code review or something, where they're looking at, I don't know, there's kind of an issue if you're deploying all the time with retroactive code review. But you could imagine a team that basically has systems that are maintaining the auto code review, and like you don't need to get a second code review unless that team basically determines this person needs to look at it before they'll accept the change. And so that, like, I would create it, like if I was at one of these big companies, I would potentially create a team to do this, because, and I would get rid of 100%. I would be like, you know, you don't need everyone to read your change. We have a team that will tell you if your change needs to be reviewed or not. Like you submit it, it takes less than a minute. You have some, you know, ETA that it has to be done by to know whether or not you're going to need code review for that change or not. So my point is that I think big companies in general won't get the biggest benefits out of this stuff. But really, I think small places can do some interesting stuff, like seeing this, how fast these things can get completed with how little effort it takes. And these are just really nice quality of life. And it's like, this person probably didn't consider that initially, you know what I mean? And maybe some other person's going to run into this and stuff. So if you can make it really fast to fix small problems for people, you can really, these things add up. And if you were like a very active maintainer before, you could have done them, but you were going to be using up all your time. So you can maintain more projects now. You can make the project bigger. There's just a lot of flexibility things give you. Yeah. I had to put like a measure on how much more productive I am. It's pretty hard, because the way I feel about these tools is that, so when I started learning programming, when I started like trying to be able to do stuff that was interesting, and I wanted to like make, say, something like Facebook, it took a long time. I mean, it was hard to get to the point where I felt like if I wanted to build a feature, I could find some way to build it. Like I didn't know if it would, I didn't know anything about scaling or anything like that, but like I could make it exist as a feature. I could like render it on the page and like do the back end stuff that needed to be done, and like it would exist. It would probably be terribly scaling, and I didn't think about any of that. But so that took a lot of time, but that felt pretty good, right? Like it felt good to get to the point where like if I had an idea, I knew I could realize it. And I think that what you start to realize later is that like it's not actually gonna work. Like you can realize it, but it's just not good enough to be able to. You got to do more than that. You got to be able to make it cheaper, or make it scale better, or make it just a higher quality. There's all these different things that have to happen. And so as I learned more skills and stuff, I got to the point where I felt like I knew a few ways to do everything. And that was good, but it meant that every time I would run into issues, I would have to think about like what my options are, and then think about how hard the option is to actually execute. And I feel like now with the AI stuff, I'm like aware of all the options, and I'm just able to execute options that are higher quality that I just wouldn't have done before, because I would be like, this is just gonna I have to take the easier path because like the easier path was gonna take me as much time as the harder path. And so now I feel like I can build a system that's just better than what I could build before, because I'm not running into these issues all the time, where I just feel like it's gonna take too much time to do something hard. And it's not like I can do the hardest things. I still don't feel like, you know, if something is really hard, I don't feel like I can do it. It's just like if I was aware of a path, or maybe if I ask about a different path, that I can get like pretty good documents. And I feel there's also some effect of like kind of the rubber ducky effect, where just like talking to these things makes it more, it just makes you realize you're not missing something huge potentially. Like a lot of times when I'm evaluating choices between say 4 or 5 different paths you can go down to implement something or do something, I'm always wondering, like, am I just completely missing something here, or is this just really off or weird? And so having like a consensus voice, basically the bots, the chatbots, that's just like, oh, this seems fine, or people do this, or, you know, I think this encompasses everything. It might not be right, but just like having a voice there that's like just giving you a second look at that, and you don't have to step out of yourself to get that second look, means that I can evaluate things a lot faster than I could by myself. So a lot of times when you have the ideas yourself, you're like you like come up with these 4 ideas, and as soon as you come up with them, it's very hard to evaluate them right afterwards, because you just spent so much time thinking about them that you're very invested one way or another. And so a lot of times I would like have an idea and then have to step away from the computer for a day or 2, or work on something else and then come back to it with fresh eyes. And so I feel like I'm just able to do that all the time without having that delay. So, I mean, if I was super motivated before, do I feel like I'm getting a ton more done than I was? No, I think the quality's higher, but I feel like I'm able to just continue moving at a very good pace. So, yeah. And at the end of the day, like, people don't realize the things that matter are like more than the code. For me, the code was always the easiest part. Deciding what you wanted to do, or how it's going to be structured, or how things were going to work so you could do, like, that's the hard part. And I don't think they can do these types of things yet, because the context is just not large enough. There's just no, like, you can tell it to factor in all these things and it's going to forget something, you know. There's just some aspect of they're not able to do all these things yet. Yeah, unfortunate, sort of annoying thing without having IP and software is that as soon as you do it once, say for example, all this stuff I'm doing, if someone wanted to copy it, it'd be trivial, because you could just show it, here's the playbook. It's like the art. It's like very difficult to come up with the art. The AI like couldn't come up with some new style for the most part. But as soon as you make the style once, it can just, here's that style again. And like, maybe it's not perfect, but you could probably get like 90% of what I have. Just being like, here, do this. Here's the style. Anyways, pretty exciting stuff. I think also, like, I've seen some people are maybe demotivated by the fact that like some of the AI tech companies have grown so much so fast, and if you weren't there, then you missed out or something. But I really do feel like this is a thing where we'll see companies in 10, 15, 20 years that exist because of the AI stuff that couldn't have existed otherwise, and those are still being built. Like, I don't know if there's any chance for my thing to be like that, but I do think we'll see companies like that, you know, companies with 10, 20 people that are just delivering higher quality stuff than large companies. Definitely happen. And part of doing all this for me is that doing all this makes it very transferable to other companies. And then maybe, you know, the biggest thing for me would be if one of those places that was doing that stuff saw this and was like, oh, that's interesting. And maybe thought it'd be valuable. Okay, let's say it did all this. Let's see how it did. It didn't do Victoria logs alerts. See how node exports. Import.
Permission requested. Command to list contents of specific folders in the Kiwi research directory.
Yeah, so it imports all these, re-exports them. But this is the alert definitions. Yep, that's what I wanted. Good. I feel like labels is always the same. Maybe it should be done in the main thing. Can you do the same thing
Updated the alert
for
group's index TypeScript file to
Fourier
remove the cluster
logs?
imports, deleted the old infra and cluster alert files, as well as the refactor plan markdown files, and created new exporter folders, each containing alerts TypeScript and index TypeScript files.
I actually don't
I then
know.
ran the TypeScript type check and lint commands, both of which passed,
Actually,
and verified the final directory layout,
don't know
which now includes 10
if that
exporter
makes
folders organized under
as much
groups infra.
sense with logging. Because logging doesn't have exporters in the same way as metrics does. You have fluent bit collectors, but they collect all the logs. There's not like different logs for different things. But I don't really want to have a hugely different pattern. But this looks good. Let's make sure coredns follows the same pattern. Yep. Let's see.
I explained that log alerts are based on content patterns rather than metric exporters, reviewed the current Victorialogs alert structure, showing an infra versus app namespace grouping, and suggested alternative ways to organize logs by detection strategy, service application, or severity. I then asked whether to keep the existing layout or explore a different organization strategy.
I messed up here quite a bit. First thing, let's get the easiest changes out of the way. This, and bare metal. Bare metal proximate. Here. Can you look at the staged changes and check in? You just make sure that's. We did this because Cloud Init is running on every reboot of the Proxmox nodes, causing SSH public the ID change for the nodes for all nodes. Ooh. And one other thing I didn't talk about, my little ramble. Pre-ramble. Yeah. So I think one thing too is there's sort of a couple different approaches to use these AI tools today that I've seen. Go. Here. Again. Huge. So I think another thing is that as a general thing, People
I committed
don't
the changes
realize
that add
how
a
hard it
stable
is.
instance it to all cloud init configurations, which prevents SSH host key regeneration on reboots and protects the global DNS snippets from accidental deletion. And the commit was recorded with the hash 256,994F.
So I think as a general thing, people don't realize how hard it is to make things that are simple to use, or like how much attention to detail there is in the things that they like to use, and how hard it is to like pare things down. You know, some people have talked about with the code stuff, the AI generated code stuff, that like the hard part of writing code is writing simple code. It's easy to understand that has less lines of code, not more lines of code. And people really, I think, underestimate the value of that type of thing, of like doing really hard work that simplifies things for the user or whatever. It's really hard to compete against that type of stuff. So I think, like, for example, Apple, the reason Apple could do stuff like this was because Steve Jobs recognized stuff like that, and I think Tim Cook kind of followed with that as well, which is rewarding these people who are kind of really paying attention to detail on different things, because he cared about that and was willing to reward that. Most companies, I think, the CEO doesn't care that much. Like, they don't understand how hard it is to do each of these things and respect it enough. So it all comes down from the top. And basically what ends up happening is that these companies in general, these large companies, the reward system is such that you're rewarded for delivering a lot of stuff, not for delivering high quality stuff. And yeah, I think that basically means that companies are going to go the direction of generate as much code as possible. And it's very hard to get back from that. I think that's not actually, I mean, it just depends on what you want to do. It's an approach. There are many approaches that work. But I think that, you know, the thing that's an advantage is doing things that are hard that other people can't easily copy, which is doing things that are simple. A lot of this is overgenerate. But my point, yeah, a lot of things work. With the AI stuff I've seen, you know, vibe coding, it's very impressive how much you can deliver, how quickly. With most of the vibe coded things I've seen, there are tons of small issues. Like buttons don't work, like basic, like things that would just never happen if you were a person doing it. And there's a benefit to just, you know, putting stuff out there and seeing if it works. But, you know, if you don't even know if your buttons work, it's hard to get to like eventually be to a like realize market what is it called, product market fit, and then come back from that afterwards and be like, no, now we're gonna make a super reliable thing. Like, it would be amazing if say Anthropic or OpenAI were ever able to get to like a super high reliability systems. Yeah, this is where I do like Grok, GROQ, Grok. I think they're a fairly interesting company. Again, it comes from having a CEO who understands how hard, like, you have to understand how hard things are to do. And I mean, I think most CEOs understand things are hard to do. Like, if they created the company and stuff, some of it's luck, but generally the people have also worked hard to some degree. But yeah, I think you need to recognize that in everything people, if you want kind of a big picture, if you're like trying to have a cohesive product. And it's hard to do that if you don't understand or respect them. I'm on them. Like, I remember there was a story with Steve Jobs where they were evaluating the operating system, I think, for iOS before the iPhone came out. And there was like two teams doing completely different approaches. And, you know, Steve sits with both teams and like thinks about this every single night for weeks about like what should happen, because it's going to make such a big impact on the long-term future of what they do for the iPhone. And so most CEOs just aren't. They're not in the weeds like that. They're like, I want an iPhone. You know, do this. And they check out and go to their yacht. You know? Okay, that's checked in. I think I should go ahead and see about this logging thing first, because I can have it start on that while I do some more commits. I haven't been keeping track of any timestamps. That's a bummer. It's so hard to do the timestamps after the fact. I have to like watch the entire video, which is fine. But it's so much easier to do them, right? Looking at Victoria Log's alert structure, you're right. It doesn't make sense to apply the same pattern here. The current structure is app error spike, infra persistent errors. Cluster templates are currently empty. Log alerts are fundamentally different because they're based on log content, not metrics. Namespace groupings versus infra, not export. Detection strategies. Spike versus persistent, based on expected behavior. Better organizational patterns would be spike detection, persistent errors, absence by service application. Yeah, I like that. I like what you're suggesting with the organizational patterns, but how does it work? How would those types of categories work when we say want to do high error, when we want to check for a spike in errors, or persistent errors? If we put those in spike detection, persistent errors, then what would be the point of the errors? Let's see what it says. I find as a general thing, I think I talked about this a couple days ago too, that the AI models are not very good at naming or grouping, because they can't take into account everything, and even when you take into account everything for grouping, a lot of times there's no right answer, and there's just really hard trade-offs about what to do. And the AIs will just flip between things and agree with you.
Explained that
And so
detection
you really
strategy
have
should
to
be treated
choose
as a configuration choice rather than a category. And I proposed reorganizing the alerts by what is being monitored using a new folder layout that groups pod errors, OOM events, and service-specific health checks. I showed how each service file would contain its own detection strategy config, and asked if this structure makes sense, or if a simpler flat arrangement would be preferred.
Detection strategy is more of a configuration choice, not a better organization. Might be what your mod. Pod errors, events. Yeah, that sounds good. Let's see. We just don't have enough alerts on logs yet to do something to really know what should happen there. I think once I get more log alerts, then it'll be more obvious. Okay, this is mostly the alerts changes. Naming. That's it. I just gotta double check some. Like it got rid of a couple logs, I mean a couple labels that maybe I want to keep or not. Let's see what we got. Runtime context. Yes, this is one of the changes I was thinking about. Basically, we created system context, which will have a runtime context, and runtime context is like K8's app prod or proxmox prod or whatever. So this is now a consistent label. Previously for the K8 nodes, we just had these kind of like custom labels. And we had environment and cluster names separately. I don't know if we still want. So keeping it would let us filter out a metric by, prod, all the prod cluster metric data, all of the management data, instead of just the management.
I created the groups level TypeScript index file and updated the main TypeScript index, added the pod errors folder with its alerts TypeScript, app namespaces TypeScript, infra namespaces TypeScript and index TypeScript files, removed the old infra and clusters directories, ran type checking and linting to verify the code, and listed the final directory structure. I explained that the alerts module now provides reusable detection strategy generators, and that alert groups were renamed from infra critical warning to logs critical warning for more accurate naming. The new Victoria Logs alert structure now includes a main entry, a combined groups index, and a pod errors group with its specific files. I explained the trade-offs of keeping the K8's cluster type and K8's cluster environment labels, noting that they make queries and Grafana variables much cleaner despite a small amount of redundancy, and I recommended retaining them for Kubernetes scrape configurations because the practical benefits outweigh the cost. Want me to add them back to relabel helpers TypeScript?
Can you add them back? You may need to check status files. This is another thing I don't like. Here we did DNS. The idea with this was like,
Permission requested. Edit relabel helpers TS file.
you have a VM, like global DNS1. That's what, like, what is the system? What is the thing? And I don't mind this. Basically, you have DNS role. So if you switched from, say, coredns to something else, you could still use that same DNS role label for the VM, for the node exporter metrics or whatever. But I think DNS roles only applied on coredns. But you can see how we basically have Ceph, Kafka, Vitas, their technologies. The benefit of this is that these are only applied on Ceph metrics. So it's like you already have Ceph underscore. Now you have another.
I edited the labeling markdown file to add a detailed K8's convenience labels section, updated the label definitions table, and noted the intentional retention of those labels. I also modified the relabel helpers TypeScript file to include the K8's cluster type and K8's cluster environment labels in the add cluster labels function and its documentation. Finally, I ran a TypeScript type check on the infra K8's project with pnpm exec tsc no emit and confirmed the changes compile.
Take a look at that alert. You can see we have node and F. Ceph, Kafka, Vitas are all technologies. Do you think we should use technology the role or the type of thing?
I explained that role labels should describe a services function and can span different technologies, while component labels are tied to specific technology concepts. And I argued that the current naming scheme follows this principle and is therefore correct. Then I asked if that framing makes sense.
No. You'd never have storage component. Metric prefixes. What is this used? Not a huge fan that calculating walrus has the same, like the Proxmox servers have the same as the machine itself, but I don't really want to add like a Proxmox. Not be terrible to do. Oh, it's a Proxmox. There was one other thing I wanted to do. I don't think there's rename key. Yeah, that's fine. This is Proxmox Ceph. I think this should be Ceph. Should be Ceph dash. And orders probably be two. DNS role. Fine. Role. F-proc. I wonder if rook-sef. Oh yeah, that's it. So I think rook-sef would be like rook-sef -k8's core prod. But I talked about this before with it. And what would you think about rook-sef 8th? This is more explicit, but it's a little bit repetitive. Rook-sef k8's core prod because rook implies that it's in Kubernetes. But then you have this weird thing, which is that we have proxmox-sef prod, and so rook is kind of indicating that it's in Kubernetes. That's such a weird thing. It's weird because the system context, you kind of want to know that Ceph first. That's what it is. And here we're saying rook Ceph, so you know that it's Ceph. The other one we're saying it's proxmox, and then saying it's Ceph, when Ceph is the more important thing. I wonder if we name it Ceph. Let's see. Keep these two. Keep Sephiroth. Fine. Yep. Then we have node type. Node role. Yep. Yep. Runtime type, runtime. This for global DNS. No, this is for the kubelet. Kubelet itself.
I explained the current naming inconsistency and proposed a service first pattern that puts the service name first, then the platform or cluster, then the environment. I suggested dropping rook because it's just the operator and adding K8s to Vides and Kafka for consistency, and I presented two options, one with the K8s prefix and one without, while indicating that I lean toward the option that includes the K8s prefix.
Gates core prod. Here it was. Oh, okay. Kind of different. $32. Oh, I see. Interesting. Here. We don't. Can you address Tropic broke? Option enter. Like I was talking about.
Permission requested. Edit coredns scrape config file.
I agree, Rook. The deployment mechanism, not the system.
I edited the coredns TypeScript scrape configuration to remove the legacy kiwi, eo/coredns role annotations and labels, updating the keep filter to only check for kiwi, eo/DNS role, and simplifying the regex, and I removed the fallback relabel rules that reference the old coredns role, leaving only the DNS role handling.
I haven't talked about on stream recorded is that in the garage where the servers are, I have some batteries from when I was living in the shipping container during COVID. And they're like 16 kilowatt hours. I have 2 of them. I only have 1 of them built right now, put together. But I get power outages here because the trees and limbs and stuff fall on the power lines somewhat regularly, especially in winter. And yeah, anyways, I've been having some outages, so I decided to get that all hooked up again. So I'm top balancing the batteries right now. So here, that'll. Nope. Focus it. There we go. Anyway. I keep checking that because you have to run the cells at pretty high voltages. Not like crazy high, but like 3.5 volts per cell. And keep them there for a bit so that they can the BMS can balance the cells by pulling current from the highest voltage cell and putting it into the lowest voltage cell. So the batteries have been sitting there for a while, so I figured it'd be good to balance them. But yeah, you want to check it because you don't want to leave them there for too long or anything. Like the less time you can leave them there, the better. I'm only going to keep mine. I think I'll probably top balance them at 3.5 volts. People do like 3.6 volts. But I think if you were charging to 3.5 volts, then you probably want to balance to 3.5. Done. VM, global DNS, yeah. Prod, DNS prod.
I updated the last reference at line 107, renamed all system context entries to the new service first pattern, and edited the TypeScript files proxmox/cefmgr Prometheus, proxmox/cefexporter, kubernetes/rookcef, cluster/core/cluster/resources/cefcluster/index, as well as the markdown file labeling, MD. I then ran a TypeScript type check on the infra K8's project, confirmed it succeeded, and explained that the new naming improves clarity, consistency, and makes regex queries easier.
This is an interesting thing. We just added K8s to all of the system context names. But for global DNS prod, I'm pretty sure we don't want to add proxmox because this would be global DNS-proxmox prod. But I don't think we want that because something like Ceph, it's actually tied to proxmox. It's not. That's why we want the proxmox and K8s there. And same thing with Vitas and Kafka and stuff. They're really tied to the clusters. The global DNS isn't particularly tied to the cluster, but it is the production global DNS deployment. usage yet? Nope. No idea how much.
I explained that multi-instance services should include the platform in their name, while single-instance services like global DNS can omit it because the platform is just an implementation detail. And I suggested using the pattern service platform environment for multi-instance services and service environment for single-instance services.
Actually, the thing is, though, is that Kafka and Vitas are deployed in core prod, but they're actually let's do. The same thing is true. I think the question to ask is, what if we migrated away self-deployed Vitas, managed Vitas? What would that? Did it have same labels? Labels serve.
I explained that the system context should describe what each service serves rather than where it is deployed, recommending names like Vitas prod, Kafka prod, Ceph-Proxmox prod, and Ceph-K, 8 prod to reflect their scopes. I agreed that this framing makes sense and suggested updating everything to follow the new pattern.
Same for... What do you think about Vitesse K8's prod versus Vitesse?
I explained that the naming pattern should be service scope environment, recommended using Vitesse K8's prod to accurately reflect its scope, kept global DNS prod without a qualifier because it serves everything, and listed the final names Ceph Proxmox prod, Ceph K8's prod, Vitesse K8's prod, Kafka K8's prod, and global DNS prod. Want me to proceed with this?
It's difficult because I imagine something like Redis, Mcached, deployed in K8, mainly used for K8, but maybe one of the proxies or DNS side K8 eventually needs to use it. Our label would stop making sense. I think by Vitesse. Basically, you have to know ahead of time. Basically, you're assigning a small scope ahead of time if you use it. Oh.
Should I proceed with this?
I agree. The labeling file. Cluster context. Yeah, we never copied over. We might do that.
I edited the labeling markdown file to replace the old system context heading and update the naming pattern explanation to service scope end, and added a table of final naming conventions. I grepped the codebase for old references to CephK8 score prod, ViteSK8 score prod, and KafkaK8 score prod, then ran a TypeScript type check on the infra K8s project with pnpm exec tsc and confirmed no errors. I also updated the Kubernetes rookceph TypeScript file and the Ceph cluster index TypeScript file to reflect the new naming references.
I guess out of order. No idea. All the alerts. Can you look at page?
I displayed the staged changes and recent commit history, then ran the pre-commit checks before committing the Alert Manager configuration that now builds Grafana URLs dynamically for Slack notifications. I committed the changes with the no verify flag and verified the new commit. I discovered that Traefik was failing to load the OAuth2 proxy redirect errors middleware because the redirect errors plugin could not be downloaded during startup due to a transient DNS lookup failure, which disabled all plugins and caused 404 responses for Golinks and other routes. I verified the middleware and plugin configuration, confirmed DNS connectivity, restarted the Traefik deployment, and observed the plugin loading successfully, restoring proper redirects, and noted that the Prometheus scrape errors are a separate issue that may require further investigation. I displayed the staged changes and the last 5 commit messages, ran the pre-commit checks, and then committed the update that changes Alert Manager's log level from debug to info using the no verify flag. The commit, identified as 350 BC10, will suppress verbose cluster reconnect and member join leave logs. I explained 3 ways to make Traefik plugins resilient: persisting them with a persistent volume claim, using an init container that retries downloads, and adding a startup probe that restarts the pod until the plugin loads, and I recommended the persistent volume claim for production. Would you like me to implement one of these options?
Okay. So basically, Traefik was having issues, which is why our Go links wasn't working, because when the servers restarted yesterday, Traefik tried to download the plugin, the OAuth2 proxy, I think, plugin, and then they couldn't download it because DNS was down, and then it just failed. Then never came back up. So apparently you can create a PVC, so Traefik will write the plugins to the PVC. It is exporter in. I'm asking why this is hard coded. The Ceph role. I thought the Ceph role was supposed to be it's the Ceph role, not the component. Ceph role is hard coded to rook Ceph. Ceph component would be the I think these are basically all good. Let's see what it does with.
Permission requested. Command to check storage classes across multiple Kubernetes clusters.
So it basically created a PVC for the plugins, and then it had to manually set up a job or pod or whatever that syncs the cache to the right directory. The persistent cache is the primary solution. Once plugin, yeah, they're cached. So I mean, it's nice to cache them. It's kind of a lot of code to cache them. But yeah, I think we still need the startup probe, which actually makes sure that traffic is healthy. Plugins are loaded, just in case the cache form for some reason.
I verified the TypeScript type check, confirmed the storage class was Ceph-block, edited the Traefik index TypeScript file to use the correct storage class, added a 100 megabytes persistent plugin cache PVC, and a init container, a sidecar sync container, and a startup probe, then ran pre-commit and formatting checks which all passed. I explained how the cache and probe handle first deployments, DNS failures, and corrupted caches, and offered to deploy the changes to the internal prod cluster for testing.
That plugin really the best way to correct errors like we need, or is there some more Can you look at our staged changes? Go ahead and I've already checked them. So
Permission requested. Fetch Traefik OAuth 2 proxy configuration page. examined the repository status, reviewed the staged changes and recent commits, and identified a major refactor of the metrics labeling system that separates runtime context from system context, renames several annotations, adds new labels, updates fluent bit configuration, and rewrites the labeling documentation. I then committed these changes with a detailed message and confirmed the new commit was created. I searched the web for Traefik forward auth and OAuth2 proxy redirect 401 errors, fetched the Traefik errors middleware documentation and the OAuth2 proxy integration guide, and ran a kubectl command to view the current middleware configuration in the OAuth2 proxy namespace. I explained that Traefik's native errors middleware proxies, instead of issuing a 302 redirect, cuts off query parameters, can return a 401 with a location header instead of a 302, and may overwrite headers needed for the redirect URL, which is why the redirect errors plugin is the recommended solution. I suggested building a custom Traefik image that pre-installs the redirect errors plugin using a Docker file and configuring Traefik to use local plugins for a cleaner deployment. Would you prefer to go this route?
Yeah, let's go ahead and
I ran git
one
status,
off
examined the stage diffs for the TypeScript files in the monitoring
this
alert groups,
create
and reviewed the recent commit history.
Docker file.
I understood that the alert groups were being reorganized by exporter
graphic.
or component instead of by category, and then I created a commit titled Refactor Infra Restructure Alert Groups by Exporter Component
Then
with the
we'll
stage changes. The new commit was
then
recorded
put
as
its Docker registry.
A270A47, leaving my branch 13 commits ahead of origin main.
Let's make sure to update graphic latest at the time, and you can get rid of the startup probe. After this, break, then come back. The network. But I'm already out of energy. Run out of energy talking to my hour and a half. I don't know if that's something you get better at. Obviously be easier if there were people to chat with. But I also don't particularly want people to chat with and ask questions and stuff because I've got stuff to do. Log. Graded? Downgraded.
Permission requested. Command to retag and push Docker image to correct registry.
Because it used to be management, but then we moved it to core. And apparently, and it says it's in core in the claude.md. But at some point it thought,
I edited the Docker file and the TypeScript file to point to the core production registry, built a custom Traefik v366 image with the redirect errors plugin baked in, and pushed it to the correct registry. I also updated the chart version to 3801 and removed the remote plugin infrastructure, so the new image loads the plugin instantly from the file system.
deploy these. I'm gonna have it check. I'm gonna have to update the variables on these. Node role. Actually, I wanted to see before, which was to get a node exporter alert to fire for it to show up on the core DNS metrics page. But we didn't have any alerts on we didn't have any node export alerts on global DNS, so we didn't get any alerts when I pegged the CPU. Now we have those alerts, so hopefully they'll show up here. I did everything right.
Permission requested. Command to check context around problematic lines in a YAML file.
Oh, fuck. Echo traffic. Search traffic. 2. No. Work. I just updated the default values. Can you check again?
Permission requested. Command to check context of remaining matches in a YAML file. I grepped the configuration files and displayed the relevant lines, then inspected the surrounding context with sed. I confirmed that the remaining matches are valid and that the previously problematic properties have been fixed, so the deployment should succeed, and I asked if you'd like me to run the Pulumi up again or check anything else.
I just tried.
I inspected the new local plugins format by running a Helm command and fetching the values YAML and the local plugins config map template from the Traefik Helm chart, then searched for the required fields and valid type options. I edited the TypeScript file in the infra K8's shared cluster resources to update the experimental comment and reflect the new configuration, and I type-checked the changes with the TypeScript compiler. I confirmed that the chart now requires type, local path, to use a plugin baked into the container. I edited the TypeScript file to replace the experimental block with a comment and configure the local plugin via additional arguments, noting that the plugin is pre-installed in the custom image at plugins-local/src/github. I explained that this approach bypasses the Helm charts volume requirement and lets Traefik load the plugin directly. I suggested redeploying to apply the changes.
DNS.
Permission requested. Command to check Traefik pod status. I checked the Traefik pod status and discovered it was using an invalid image name because of a leading slash in the registry configuration. I edited the TypeScript files in the infra /k8/shared/cluster/resources/Traefik directory to correct the image construction, removing the empty registry value and updating the constant definitions. Then I deleted the failed pod so a new deployment could proceed. The image should now be Docker registry, core prod kiwi research, net/Traefik v366.
Wonder why I'm not getting the Currently at alerts. Current refactor. Is void. Go ahead. I think. Looks healthy to me.
I ran a git diff on the monitoring directory, read the default Victoria metrics alert Helm chart, performed a web search, and fetched the VM alert documentation and a GitHub. I inspected the Traefik pods and logs, verified the custom image, and that the redirect errors plugin was loaded, and checked the middleware configurations for both ingress route and HTTP route. I then tested the Galinks endpoint from inside the cluster, confirming a 302 redirect to the SSO sign in page with the original URL preserved, and identified that the earlier 429 response came from the OAuth2 proxy inflight request rate limiter. All components are functioning correctly despite an unrelated HTTP route middleware reference issue. I explained that the in-flight rec middleware with a limit of 1 is in the middleware chain for all protected routes, causing every concurrent asset request to be blocked, and that it should only be applied to the OAuth2 proxy OAuth endpoints. I outlined options to remove it from the main chain, increase the limit, or remove it entirely, and suggested a better approach of rate limiting only the token refresh endpoint. Would you like me to? 1. Remove the in-flight rec from OAuth2 proxy stack, used by apps like Golinks. 2. Add it only to OAuth2 proxy's own ingress route for OAuth endpoints. Can you share all the labels on one of the firing alerts from the Alert Manager UI? I want to verify if the group level labels, group, severity, are actually being applied to the alert sent to Alert Manager. I explained that the group label is correct, so routing isn't the problem, and identified likely causes such as invalid or expired Slack webhook URLs, template rendering errors in the Grafana URL templates, or network connectivity issues preventing Alert Manager from reaching Slack's API. I then instructed you to check the Alert Manager logs for errors by running a kubectl command that tails the last 100 lines and greps for error, Slack, failed, or warning messages.
Client actually request auth not happen transparently. The redirect the client.
I explained how Traefik forward auth subrequests cause multiple concurrent token refresh attempts, leading to refresh token claimed twice, errors, and I suggested several mitigations such as configuring OAuth2 proxy with I switched to the management cluster, inspected the Alert Manager pods and logs, and discovered a template error caused by the Grafana host variable being defined after it was used. I edited the Alert Manager config TypeScript file to move the Grafana host definition before it is referenced and removed the duplicate definition, then ran the TypeScript type check which passed. I explained that the fix involves defining Grafana host in the time range template before the dashboard URL template uses it, and offered to run pre-commit checks before deployment.
Traefik makes a server-side sub request to OAuth2. Client doesn't see it. Checks the cookie. The client never requests that. Are there any controls for this? Then
I explained that Traefik's native forward auth lacks caching or request coalescing, and pointed out 2 open feature requests for a cache lifetime option and external caching suggestions. I then described several workarounds, including raising the concurrent request limit from 1 to about 5, adjusting OAuth 2 proxy cookie refresh settings, using a Redis session store, removing the rate limiter, or employing a custom authentic specific plugin. And I asked if you'd like me to increase the limit from 1 to 5.
increasing the limit won't work because the issue is we get literally just 2 requests. If we get 2 requests at exactly the same time, you have 2 tabs open, or the browser tries to pull 2 endpoints at the same time, then you're going to get 2 requests at exactly the same time. And increasing it to 5 doesn't work, and they keep alternating. Increasing the limit would mean get those errors again. We can do that, but I don't think they were occasional errors. Would continue. Continue. This one's a new because we just did the node exporter alerts. So all 3 of them have packet drop. Oh, that's normal. Solved on or above. Let's figure out what to do about this token duplication issue. Then I'll commit the token duplication issue fix. I'll commit this alert manager fix. Play everything. Take a break. Not taking very many steps forward here.
I explained that the minute interval errors stem from a known OAuth2 proxy race condition when refreshing tokens without session locking, and I examined the DEX configuration, showing a 3-second reuse interval, and the OAuth2 proxy settings, cookie refresh set to 1 hour. I then recommended increasing DEX's reuse interval to around 60 seconds as the cleanest way to stop the constant refresh failures.
How often we're getting that more frequently. Okay, go ahead and rate limiting. First commit which I've already checked them, so you can now go ahead and rate limiter and
I ran
update.
git status to check staged changes and committed the Traefik changes with a custom image and pre-baked redirect errors plugin. Would you like me to update the DEX reuse interval from 3 seconds to something longer like 60 seconds?
Of all the context.
Permission requested. Command to show diff stats and OAuth2 proxy changes.
Go ahead and commit the current is I've saved them and checked them. You can commit. I just want to let the while it's still hot.
I committed a fix for OAuth2 proxy concurrent request handling, removed the OAuth2 proxy and flytrack rat, and noted that the changes need to be deployed to core production for the DEX reuse interval change and to internal production and other clusters using OAuth2 proxy for the middleware chain change.
Push. Boy. Okay. I'm taking. I'll be back in about.
searched the Strimzi operator configuration, read the relevant TypeScript and YAML files, and discovered the default memory limit of 384 MB was too low for 3 operator replicas. I updated the Helm values to raise the memory request to 512 MB and the limit to 768 MB, then ran the pre-commit checks to validate the change. I explained that the increased memory should relieve the pressure caused by multiple node pools. I queried the Strimzi cluster operator pods with kubectl, listed the available contexts, and inspected the alert definition, discovering that the leader pod was using 347 MB of memory, 90% of its 384 MB limit, which exceeds the 80% alert threshold. I then edited the TypeScript resource file for the Kafka cluster to keep the request at 384 MB and raise the limit to 512 MB, resulting in about 68% usage and safe headroom. Permission requested. SSH into global DNS 1 to check network stats. Permission requested. SSH into global DNS 1 and execute system commands. Permission requested. Command to SSH as Ansible user and check network. Permission requested. Command to check detailed network stats on global DNS 1. Permission requested. Command to investigate packet drop reasons on a remote network device. Permission requested. Command to check IP4 traffic on IP6 network. Permission requested. Command to calculate drop rate and verify multicast on a remote network device. Permission requested. Command to calculate drop rate and trace packets on a remote network device. I SSH'd into the 3 global DNS VMs, examined their network interfaces, and discovered around 131,000 dropped receive packets on each ETH0. Then traced the cause to IPv4 ARP, DHCP, and multicast traffic arriving on an IPv6-only network, which the VMs cannot process. I explained that these drops are expected behavior for IPv6-only VMs receiving IPv4 broadcast traffic, and that the VMs are otherwise functioning correctly. I offered several options to adjust the alert, such as excluding the global DNS platform, raising the threshold, creating a separate alert, or simply accepting the occasional alert. Permission requested. Command to check Proxmox network config and filtering options. Permission requested. Command to find tap interface and verify filtering possible on a Proxmox server. Permission requested. Command to test NFtables filtering on global DNS 1. Permission requested. Command to check Kubernetes VM network configuration. Permission requested. Command to compare VM network configs and check traffic on specified Proxmox servers. Permission requested. Command to check global DNS network settings. Permission requested. Command to check Kubernetes node network settings. explained that a prior Pulumi deployment was interrupted, leaving resources in an unknown state, and that the Helm release timed out because the Strimzi operator pod was pending due to anti-affinity rules and untolerated taints. I investigated the pod's status, events, and deployment strategy by running kubectl commands, read the deployment strategy from the Kubernetes manifest, and edited the TypeScript index file to adjust the strategy to allow one unavailable replica. I recommended deleting the stuck pod, refreshing the Pulumi state, and rerunning the Pulumi up command with the updated strategy. I deployed the Strimzi operator changes, verified that the pods were rolling out with the new memory limit of 512 MB and the updated deployment strategy, and confirmed that all 3 new pods are on the new replica set across the 3 worker nodes. I also noted that there are 11 pending operations from a previous interrupted deployment and suggested running a refresh to clear them. Permission requested. Command to add logging to debug NFtables on calculating walrus, PVE, prod, Kiwi Research, net. Permission requested. Command to check Helm release values for the Strimzi deployment in the Kiwi Core Prod context. Permission requested. Command to check Helm release resource values for the Strimzi deployment in the Kiwi Core Prod context. Permission requested. Command to check current Helm values for the Strimzi deployment in the Kiwi Core Prod context. added an IPv6-only network section to the TypeScript configuration file and created a shell script with NFtables rules, then set up a system service and Ansible tasks to deploy and enable it on all Proxmox nodes. I explained that the NFtables rules, script, and service persist across reboots because the service runs at boot, and listed the types of traffic blocked. I reported that packet drops on the IPv6 only VMs fell from about 46 per 30 seconds to 0 per 30 seconds.
Longer break than I expected. I did check some stuff as it was going. Cells are almost fully balanced too. Okay. Going on here. I think we fixed the throttling. Possibly, no. Not fix the throttle. Traffic blocked. Did it make a document like a yeah? Do all these rules changes reset on reboot without the Proxmox nodes? Up, come here. Come. We're here.
I explained that the NFtables script at /usr/local/sbin/NFtables IP6-only network. SH and the system service file at /etc/systemd/system/NFtables IP6-only network. Service remain on disk, and the service is enabled with a symlink, so it runs at boot, reapplying the in-memory NFtables rules. I noted that the services type equals one shot and remain after exit equals yes caused the script to recreate the bridge filter table and protect the VMs after each reboot. I also mentioned that rerunning the pulumi command will ensure those files stay in place and the service stays enabled. I created a new markdown file at infra/proxmox/notes/ip6-only network filtering. MD documenting the problem, solution, implementation details, persistence behavior, operations, troubleshooting steps, and future considerations for IP6-only network filtering. Want me to commit these changes?
IPv6-only VMs receive unwanted layer 2 broadcast traffic. ARP requests for IPv4. We don't have those. V4D, okay. All of the above wrapped in 802 VLAN tagged version.
Permission requested. Command to check Helm release values after update.
Traffic archives. NFtables bridge rules. Or it reaches. Can't filter at it. All traffic is already. Can't filter. I see. Do you think all of this is reasonable?
I explained that we block traffic at the bridge before it reaches the VMs, highlighting the cleaner networking and true zero drops, but also noting the added complexity, and that the drops were only cosmetic. I also pointed out that a simpler fix would be to adjust the alert threshold or exclude expected drops, and I asked which approach you'd prefer.
Cleaner networking, VMs only. Fixes the.
Permission requested. Command to check Helm manifest for the Kiwi Corprod Kafka environment. Permission requested. Command to check Kafka manifest limit section. Permission requested. Command to perform dry run Helm upgrade for Strimzi Kafka operator. Permission requested. Command to check Helm values for the Strimzi deployment in the Kiwi Corprod context. I explained that OP nsense works at layer 3, so it only sees traffic that needs to be routed and cannot filter layer. Permission requested. Command to test Helm upgrade with empty CPU limit. Permission requested. Command to test Helm upgrade with null CPU limit.
Yeah, what is it? Yeah, I mean, I kind of prefer this just because then you know if something's actually wrong instead of just like having a threshold. But it'd probably be nice to do this somewhere else, which is probably means not having all these devices. The issue, the reason this happens is because there's a switch with a bunch of L2 a bunch of devices plugged into it that's connected to the 100 gig switch. I have a Unify switch, my home switch. Let's see where we're at. Resources limit. Huh. Oh.
Permission requested. Command to manually upgrade Helm release. Permission requested. Command to check Helm manifest after upgrade. Permission requested. Command to upgrade Strimzi Kafka operator with custom values file. Permission requested. Command to check Kafka manifest after values file upgrade. Permission requested. Command to complete Helm upgrade with all values for the Strimzi Kafka operator. I explained NFtables as Linux's packet filtering framework, describing its hierarchical model of tables, chains, and rules, the different families such as bridge, and how chains hook into specific points of the network stack. I detailed the packet processing flow, showing that packets traverse hooked chains, and the first matching rule with a terminal action decides the outcome. I also walked through our bridge configuration, creating a bridge family table, a forward hooked chain with an accept policy, and adding a rule to drop ARP frames before they reach the virtual machine.
Fire thing. Let's see. Main hook into Big points in the kernel's network. For bridges, specifically forward, patches trafficking.
Permission requested. Command to fix prettier formatting issue. I edited the Strimzi Kafka operator default values YAML file to include CPU. Null, then ran a sequence of Helm upgrades, I edited the Strimzi Kafka operator default values YAML file to include CPU. Null, ran a Pulumi update, performed several Helm upgrades without reuse values, and verified with kubectl that both the operator and the Kafka controllers no longer have CPU limits, then refreshed the Pulumi state and fixed a prettier lint issue in a markdown file. I explained that Helm merges values and retains defaults when a key is omitted, that Pulumi's Helm provider strips null values, and that using a fresh Helm upgrade with an explicit null in the values file correctly removes the CPU limit. I confirmed the final deployment shows no CPU limits, and the deployment strategy has been updated as intended. Permission requested. Command to verify current state of Kafka cluster. I checked the repository status and listed the staged files. Then I committed the NFtables IP6-only filtering changes with the message, feat infra. Add NFtables bridge filtering for IP6-only VMs. Adding the TypeScript files infra /proxmox/nodes /ansible /proxmox nodes playbook. TS and infra /proxmox/nodes /config. TS as well as the markdown file infra /proxmox/notes /IP6 only network filtering. MD in commit to CB1A05. Permission requested. Command to check Helm values for the Strimzi deployment in the Kafka namespace. Permission requested. Command to test Helm with YAML null configuration. Permission requested. Command to export current values from the Strimzi operator ref 33 FFC2 in the Kafka namespace. Permission requested. Command to upgrade Strimzi Kafka operator with explicit null memory limit. I edited the TypeScript file to add the allow null values parameter, then ran Pulumi up, inspected the Helm manifest and values, and discovered that null values were being stripped, so I performed a manual Helm upgrade with an explicit CPU. Null entry in a temporary values file verified that the CPU limit was removed from the deployment and pods, and finally refreshed the Pulumi state. I explained that Pulumi's Helm provider does not correctly pass null values even with allow null values set to true, citing related Pulumi and Helm issues.
All right. Just figure this out in a minute. Although that's tonight. In 4 hours, maybe I'll try a little bit more. We have some.
I explained the repetition issues in the current dashboards and presented 4 more compact representation options, highlighting the pros and cons of each. I recommended the hierarchical shorthand format as the most token-efficient solution, showed a token count comparison, and offered to either fully convert a dashboard, build a TypeScript parser, or refine the syntax. How would you like to proceed? I transformed the node exporter json dashboard into a concise GDSH file, added detailed syntax refinements, showed a 92% line reduction, and documented edge cases such as empty titles, variable panels, repeat panels, and complex transforms. I also presented a line count comparison and asked whether you would like me to build a TypeScript parser, convert the coredns dashboard, or refine any specific part of the syntax. Permission requested. Edit node exporter, G-file. I wrote the node exporter, G-dashboard file and the G-MD specification file and saved both. I explained the syntax decisions I made for the GDSH format, such as using ASCII safe arrows and separating queries and panel options. Would you like me to? 1. Remove the old template, txt. 2. Convert the coredns dashboard to validate the format handles heat maps and regex overrides. 3. Start building a TypeScript parser. I removed the old template, txt text file and created a new network/coredns, G-GDSH file containing the coredns metrics dashboard. I explained several syntax refinements from the coredns conversion, including inverted thresholds, heat map options, regex overrides, conditional thresholds, and empty rows, and compared line counts, showing about 92% reduction for both node and coredns dashboards while preserving all semantic information. I listed the updated files, noting the deletion of template, txt, the new compact GDSH files for node exporter and coredns, the G-MD markdown specification, and asked if you would like me to build the TypeScript parser that converts GDSH files to grafana-json. I explained the trade-offs of GDSH, TypeScript, and YAML approaches for defining Grafana dashboards, listing their advantages and disadvantages. I compared them in a table and recommended using TypeScript because it already fits the stack, offers type safety, reusable patterns, and avoids a custom parser while remaining fairly compact. I asked if you would like me to prototype a TypeScript dashboard builder. explained how JSX offers declarative, readable syntax, component composition, and TypeScript type safety for building Grafana dashboards, showed a TypeScript JSX example of a node exporter dashboard, and a simple renderer that walks the React element tree to produce Grafana JSON. Compared this approach to plain TypeScript and GDSH, highlighted its visual hierarchy, reusability, and advanced patterns such as context and conditional panels, and asked if you'd like me to prototype the React components and renderer.
Now we're having some fun. So, yeah, reading these JSONs is not viable long term, and I do want the LLMs to be able to make improvements over time. The benefit of the JSONs is you can mess with stuff in the UI and then save it to the JSON quickly, which is nice. But I'd rather have consistent dashboards that are easy to kind of control the whole set of dashboards. And so I think having something in the code that the understand is going to be the best way to do that. So that's why I was kind of messing around with these like text rendering versions. This one was designed to be like easy to visualize, and it was still too big. Then there was like this, but then it's like, I don't want a parser for this. I don't really want YAML either. We use TypeScript for everything else. It seems obvious you would just use TypeScript for this. If you're going to use TypeScript, the obvious thing to do would be to use React to be able to design and lay out and build the components and stuff. So yeah, this is kind of a fun little thing. We use Moon for our repo, so it's not too hard to actually, it's not doing this right now, but we can put this as a library inside of our project that we just built as a dependency for this. And then whenever we deploy, we can just make sure these are built, which is nice. This is actually something that could become an issue, which is maybe we want to have separate build targets for depending on what you deploy. The Pulumi deploy scripts I have aren't really designed for that. It's maybe something I should have thought about, but we'll see. It's an issue that can be addressed. Basically, we have a single Moon YAML for all of the K8 stuff, which means like if I wanted to build the Grafana stuff, that might take a little bit of time. And if you're deploying anything besides the management cluster, you don't really need to do that. So that's where it would be better to have more targets. But then like Pulumi Interactive, which is one of the commands you can run here, it's its own target, but it doesn't actually like run Moon commands. It runs Pulumi directly. So that would have to be updated to run Moon commands. Doable. Nothing crazy about any of that. Where is it writing all this? I just turned the sauna on, but I do want to use up all my tokens. This is pretty fun. So again, the benefit of this is you build the component, you just use it on all your stuff. If you want to change it, you can update all your dashboards at the same time, which is really nice. If you want to add some features or whatever, you do all that. Basically, we'll output this React to a JSON model, which will be built every time, and then we'll go in the build directory, and when you deploy it, it'll just get copied over. And Grafana is already designed with these kind of like panel component design anyway, so it lends itself pretty well to React. Build no dash.
I added a new grafana-react library under the monitoring directory, creating a package JSON, a TypeScript configuration, type definitions, React components, a renderer, an index file, and a build script. And I also added a new TSX dashboard for the node exporter. I marked the related to-dos as completed and explained how to install dependencies, build the dashboard to JSON, and highlighted reusable components, query helpers, multi-query panels, and repeat panels, noting the line count comparison between the original JSON, GDSH, and the new React format.
Yep. Done. This may be something worth open sourcing. It's a lot of work to open source stuff. Claude changes. Can you move the grafana-react to at a scripts and make it a how does this work? Yeah, it has a build step. Build. Make it CLI a nicer CLI script like Bloomy Interactive. And hook this up to Moon so that it runs on every so that it runs as part of the build step to generate the JSONs. As well as that tests. That's all the components and organize them nicely. The components nicely. Basically, we want grafana-react to be fully good open source. Make sure to test this out with DSX dashboards. With DSX dashboards, this out in our infra with TSX dashboards created from the node example of JSON and core. That's example. Add any additional features. Cool. Let's see it go. And I gotta go. I think I'm going to stop the stream because I'm gonna be gone for quite a bit. Thanks.